For lecture number 2, what you actually have is the explanation of how a muscle is voluntary, or what exactly allows the muscle to do what your brain tells it to do. So again, it's a bunch of vocabulary words. So again, we're going to draw the vocabulary words, okay? So I have another blank piece of paper, and this time we're going to draw on the paper vertically. Yeah, you can use the back of your notes or something.
That's what I did.
Yeah.
It's just easier.
I'm going to use pen to write, and then I'm going to use pencil to draw. Okay, so this is going to be for lecture number 2. So I'm just going to write that in the corner. This is period 4, lecture number 2. What we're going to be drawing is called a neuromuscular junction. Oh, Lisa, can you hit the lights, please? Thank you. A neuromuscular junction, which is basically what allows muscles to be controlled or allows them to be voluntary. Yeah. So a neuromuscular junction is a combination of two things, two body parts. Can you guess what you need in order to have a neuromuscular junction? Yeah, Julie.
Muscle.
Muscle and
Neuron.
a neuron, which is essentially a antenna connected to your brain, right? Your brain is going to tell your neuron to do something to the muscle. Junction just means a connection. So a neuromuscular junction is formed whenever you have a motor unit. A motor unit is a neuron plus a fiber. So specifically, it's a neuron called a motor neuron combined with all of the muscle fibers it controls. So a motor unit is a motor neuron plus the muscle fibers it controls. And that's the combination that forms a neuromuscular junction. Notice we use the word motor quite a few times here. What does the word motor even mean? It has to do with movement. So I'm just going to add a little side note about the word motor here. The word motor is actually something that converts one form of energy into mechanical energy. For example, you have a motor in your car. It converts what into mechanical energy? Gas. Converts the gas, allows your car to move. In your body, the neuron is actually going to convert electronic signals or electric signals into chemical signals into mechanical energy. Okay, so we're going to start by drawing the motor neuron, and then we're going to draw the muscle fiber it controls. So we're on this paper. I'm going to draw two things. I'm going to draw the motor unit here, and then I'm going to draw a zoomed in version here. Okay, so about 1/4 of the paper and 1/4 of the paper. So let's go ahead and draw a neuron. I'm going to use a pencil just in case I mess up. So I'm going to draw a motor neuron. And a motor neuron looks like a chain of sausages. What? Oh, I'm coloring it in, but I guess it's not showing very well. So I'm coloring in the whole thing. And at the end of a motor neuron, you have these little branches or little antennae that come off of it. And at the end of these branches, you have this structure, which we'll zoom in on later. So this is my motor neuron, so I'm going to go ahead and label that motor neuron. This is my motor neuron. It's going to get signals from your brain and then convert that signal.
Is the whole thing a motor neuron?
Yep, the whole thing is a motor neuron. So you're going to get signals from your brain and then convert that signal or that energy into movement of the muscles. So each one of these little things here at the end of the motor neuron is connected to a muscle fiber. So I'm going to draw a muscle fiber connected to this little extension here, and then we're going to draw another fiber here. And a muscle fiber is just another word for muscle cell. Kind of looks like music notes. So each one of these is a muscle cell or muscle fiber. So according to this picture, how many muscle fibers do you have? 4. 1, 2, 3, 4. 4 fibers or 4 cells, okay? In each cell, what organelle must you have?
Nucleus.
Nucleus, how many? Many, more than 1. So I'm going to draw a couple of nuclei, random spots. I'm going to label the nucleus there. And of course, the muscle cell is striated because of those Z lines. So we're going to draw really light striations which are formed by the Z lines of the actin protein. And right here, where you have the neuron attached to the muscle, that's called a neuromuscular junction. So how many neuromuscular junctions do you have in this unit? 4. So something to note is this whole thing, the motor neuron plus the muscle fibers, is known as the motor unit. And Monday, what we're going to do is we're going to zoom in on the neuromuscular junction.